All right, 7.3, proving quadrilaterals and parallelograms. So we're going to do a little warm-up review, some skills we're going to need for this section. So using these points, A, B, C, D, to find the indicated slope or measure. Find the slope of AB. So that's going to be right here, AB. Remember, slope is y minus y over x minus x. So the slope of AB is going to be, remember, this is axis y, x, y. So I can do 5 minus 1 or 1 minus 5, doesn't matter. Okay. With doing 5 minus 1, that means I'm going this direction. That means I need to do negative 2 minus a negative 5. I'm not going to work the problem out and I will erase this, but if I did 1 minus 5, then I would do negative 5 minus negative 2. Okay, so there's not one way to do it. Whatever works for you, as long as you're consistent and go the same direction. So on the top, 5 minus 1 is 4. On the bottom, this becomes plus. So 5 minus 2 is 3. So that is a slope of 4/3. I don't know why I just did the slanted line. Find the length of AC. So for length, we're going to be using A and C here. So the distance formula, remember, is a big old square root. All right. And then hitting all the wrong things. Remember, I like to do this ahead of time. Okay, and then fill in the numbers. Right? So the length of AC is going to be negative 2 minus 3. Okay, so x minus x and y minus y. 5 minus 2. Now what it's going to give me is negative 5, remember, squared, plus 3 squared. That gives me 25. Remember, negative times negative is a positive, plus 9, so the square root of 34. So that's the distance of AC. Now, if I did that on a calculator and did the square root of 34, we could get an approximate number, but it's not going to be exact. So approximately 5.83. But that's a rounded number. All right? So, some more theorems. The parallelogram opposite side converse. So if we know that both pairs of opposite sides of a quadrilateral are congruent, so these two are the same, those two are the same, then we know it's a parallelogram. Also, the converse of what we learned earlier, if these two are congruent and these two are congruent, opposite angles, that means that quadrilateral is a parallelogram. So let's look at this. It says an amusement park ride has a moving platform attached to 4 swinging arms. The platform swings back and forth, higher and higher, until it goes over the top and around in a circular motion. In the diagram below, AD, right here, and BC represent 2 of the swinging arms. DC is parallel to the ground, L. Explain why the moving platform AB is always parallel to the ground. Okay? Well, if you look at it, opposite sides are the same, opposite sides are the same. So ABCD is a parallelogram because opposite sides are congruent. So AB is parallel to DC. And AB is parallel to line L. By the transitive property. So if AB is parallel to DC and DC is parallel to this, that means those two are also parallel. All right, for what values of x and y is this a parallelogram? Well, if it's a parallelogram, we know these two are equal. Problem is, we have a y and x. We can't do anything about that. But these two must also be equal. So I can start off by saying x plus 9 equals 2x minus 1. I'm going to subtract x from both sides. I'm going to add 1 to both sides. That's going to cancel. That's going to cancel. That's going to give me 10 equals x. Or x is 10. Okay? Now we got to solve for y. So we know y is equal to x plus 7. We know this is 10. So y equals 10 plus 7. Y equals 17. All right, more theorems. Opposite sides parallel and congruent theorem. If one pair of opposite sides are congruent and parallel, then the quadrilateral is a parallelogram. So before we said they both had to be parallel or they both had to be, two pairs of equal. But what it's saying is if one pair of them is both parallel and congruent, then we're fine. We know the quadrilateral is a parallelogram. And the converse of what we learned earlier, if the diagonals bisect each other, then we have a parallelogram. So if when they cross, these two are equal and those two are equal, that means this is the midpoint on both of them. We have a parallelogram. All right. This doorway shown is part of a building in England. Over time, the building has leaned sideways. Explain how you know that SV is equal to TU. All right. Well, ST is congruent and parallel to VU. So, STUV is a parallelogram. So, opposite sides, SV and TU, must be congruent. All right? Remember, anytime you need to, hit pause. All right. For what value of x is the quadrilateral a parallelogram? Well, what we have here is we see that these two are equal to each other. Therefore, these two must be equal, because this is the midpoint, to make this a parallelogram. So I just have to say 5x minus 8 equals 3x. Now in this case, I'm just going to subtract 5x from both sides, which gives me negative 8 equals negative 2x. But then when I divide, I get rid of the negative. X is 4. Okay? And if I want to test this and plug it in, 4 times 3 is 12. 4 times 5 is 20, minus 8 is 12. It works out. All right, show the quadrilateral is a parallelogram. Okay, so what are some ways we can do this? And that's going to be answered on the next slide. So we can show that both pairs of opposite sides are parallel. Let's go back. You don't have to draw on this, I just want to talk about it. So if I show that this is parallel to this, and this is parallel to this, that is one way of doing it. Okay? We can show that both pairs of opposite sides are congruent. So if we show that these are equal and those two are equal, we have just proved it a parallelogram. Show both pairs of opposite angles are congruent. So again, if we showed these two are congruent, along with those two being congruent, that would prove parallelogram. Show the angles, the diagonals bisect each other. So if we measured from here to here and from here to here, and we found out that this equals that and that equals that, in other words, this is the midpoint of both lines, we would prove that it's a parallelogram. Show that one pair of opposite sides is both parallel and congruent. So if we showed that these two sides were congruent and parallel, or if we showed these two, oh, that doesn't work, does it? We showed that these two were parallel and congruent, that would prove the parallelogram. So there's a lot of different ways to do it. Different work required for each one, but it's kind of like your choice. Show this quadrilateral is a parallelogram. Okay, so I think personally the easiest way to do this, since this is on a graph, the requires the least amount of work, is just to do the slope, and that requires counting. So the slope of AD, all right, if I count down 1, 2, 3, right 1, 2, 3, so -1. In other words, down 1, right 1, down 1, right 1, and so forth. Well, if I go over to the opposite side, BC, I can go down 1, right 1, down 1, right 1, down 1, right 1. This also has a slope of -1. So I know that these two are parallel. Now for AB, I need to count up 1, 2, and right 1, 2, 3, 4, 5. And then down here for DC, I'm going to count up 1, 2, and right 1, 2, 3, 4, 5. I've just proven that these two are parallel. Okay, so both pairs of opposite sides are parallel. Okay, so that's probably the easiest way to do it. If it wasn't graphed, we could still just use the y minus y and x minus x and do that 4 times. If I wanted to, I could have just done these two and then done the distance formula from here to here and here to here. But that requires a lot more work, so I take the most efficient way to do it. Okay? Now, if you ever had a drawing where, let's say, your shape looked like this, and you could literally just count the distance, the length, then that would be a time saver right there. So you want to do what's going to be the correct answer, but also the most efficient. And you have choices.